We've been talking about types of reactions, and the first type of reaction was a combination. And combination reactions are characterized by two or more reactants combining to form only one product. And then within combination reactions, there are different types or subcategories. So here's the second one, a nonmetal reacting with oxygen. When a nonmetal reacts with oxygen, you get a nonmetal oxide. The formula of that oxide is unpredictable and can vary with temperature and pressure. So you can't even say, okay, carbon and oxygen always do this, nitrogen and oxygen always do that. It can depend on several different factors. The general form here is the nonmetal plus oxygen yields a nonmetal oxide. Because these are unpredictable, if you are asked to write an equation, we have to give you some sort of information about what the product is. The example here is sulfur reacting with oxygen gas. In the presence of heat, this forms sulfur dioxide gas. And the picture here, the action is actually happening in this deflagration spoon where sulfur is burning. When you ignite sulfur, it burns, it combines with oxygen and forms sulfur dioxide. So here are examples for these. Write balanced chemical equations for these combination reactions. And you're given the entire word sentence because you can't predict what the product is. Nitrogen gas is heated with oxygen to give dinitrogen trioxide gas. So to write these, we need to do what you hopefully were studying for the quiz today and writing formulas for elements and compounds from their names. Nitrogen, excuse me, I must have swallowed a frog. Nitrogen gas. Well, we know the symbol for nitrogen is N. Anytime you have an element, you need to ask yourself, is that one of the 7 diatomic elements? Yeah. It is. And so the formula for nitrogen is N2. It says gas, so we should put gas in parentheses. That's the state symbol. Is heated with oxygen. So oxygen is also one of the reactants, plus, is oxygen a diatomic molecule? Yes. Yes, it is. Remember that sentence, horses need oats for clear brown eyes. So here we have need for nitrogen and O for oats. And that's also a gas. To give, this is where we have the arrow. How do we indicate that heat is involved? We put a little triangle, a delta sign. It looks a little bit like a campfire above the arrow. And then the formula for the product we have to get from the name, dinitrogen trioxide. So dinitrogen means there's 2 nitrogens, trioxide, there are 3 oxygens, and this is also a gas. So now we have an unbalanced chemical equation, and we need to balance it. So I'll just start over here. Oftentimes you can just start left to right. N2, you have N2 on the right. So 2 nitrogens on each side, so those are okay. And then let's look at the oxygens. How many oxygens on this side? 2. And how many on this side? 3. So we have 2 on one side and 3 on the other. We can't take some away. We can't change the subscripts. We can only put a coefficient in front of the formulas. So what might be a good thing to do? We'll put a 3 in front of oxygen, O2. That'll give us 6. And then if we put a 2 over here, that'll give us 6 oxygens. Remember, the coefficient multiplies all the subscripts. So we have 2 times 3, 6 oxygens, and 3 times 2, 2 oxygens. But did that change the nitrogens? Yes. Yes, it did. Now we have 4 nitrogens here, so we need to go back over here and fix things up by putting a 2. Any questions? I noticed with the students in my activity session this week that some of them initially were very confused about the balancing, but then once we started doing it and they started working through it, it wasn't so bad, right? It got a lot easier, huh? So if you're confused about this, get some help right away before you lose lots of points on an exam or on the homework, okay? Because it's not rocket science, but it is very confusing at the beginning. And I will bring Legos to office hours, and we can play with blocks if that's helpful, because sometimes it is. I should probably just keep some in my office. Okay, so any questions about this one? Let's do the next one. Chlorine gas is heated with oxygen to give dichlorine monoxide gas. First step is to write the formulas. So chlorine gas, Cl, is it diatomic? Yes, it is. So Cl2, it's gas heated with oxygen. So oxygen is a reactant. The arrow, we're going to have that delta again to indicate that heat was involved. Dichlorine monoxide, what's that formula? Cl2 dichlorine monoxide means one oxygen, and that's a gas. Which element is not balanced in this equation? The oxygen. So there's 2 on this side. There's only 1 on this side. So if I put a 2 in front of Cl2O, I can get 2 oxygens. I have 2 on each side. The only way you can change the number of atoms on each side is the coefficient in front. You cannot change the formula. Really tempting sometimes. Don't do it. Now I have 4 chlorines here. And so I'll go over and put a 2 in front of Cl2 and get 4 chlorines on the left side as well. Any questions? So that's the reaction of a nonmetal with oxygen gas. That's one type of a combination reaction. Another type of combination is a metal with a nonmetal. When this happens, the product is going to be an ionic compound. So a metal reacting with a nonmetal gives us an ionic compound. The picture here is of sodium, metal, and chlorine gas reacting to form sodium chloride. Sodium chloride is something we eat every day, whether you realize it or not. It's in pretty much all of your food, and it's necessary for life. And it's in the salt shaker at home, and we don't really think much of it. But when you make sodium chloride from the elements, it's a rather vigorous exothermic reaction, somewhat explosive. And we've got the sodium metal, which is very reactive, and chlorine gas, which is toxic. And we put them together and form sodium chloride, and it's essential for life. So metal plus nonmetal. Here's the metal, sodium, and here's the chlorine gas reacting to form the nonmetal. Again, one product. There's something I forgot to say about that on the PowerPoints. If this metal is one with a predictable charge, group 1A, 2A, 3A, zinc, silver, cadmium, then the formula for the product is predictable. If this is a transition metal or one of the others that would need a Roman numeral in its name, we're going to have to give you a clue about what the charge is on that metal ion. So some of these are predictable and some are not. Write a balanced chemical equation for each of the following combination reactions. Here we have calcium metal is heated with fluorine gas to yield solid calcium fluoride. So the metals are all just monatomic. It's just the element symbol. So calcium is Ca, that's a solid. Fluorine, what's the formula for fluorine? F2. It's one of those 7. That's a gas. We have an arrow, heated with. So we need to put the triangle. And then the product is solid calcium fluoride. So we need to look at the ions involved. We've got calcium and we've got fluorine. What charge does a calcium ion take? 2+. This is predictable from the periodic table. And fluorine has a -1 charge. And so we're going to look at the charges on those and see that the formula must be CaF2. And they tell us that that's solid. Is this equation balanced? Yes, it is. Sometimes they are without any coefficients. Manganese metal reacts with bromine vapor to give crystalline manganese 4 bromide. Well, what's the symbol for manganese? Mn. So Mn, and that's going to be a solid. There's only one metal that's liquid at room temperature, it's mercury. All the other metals are going to be solids. Plus, it's reacting with bromine. What's the formula for elemental bromine? Br2. And what's the state on this? So I've got one person saying gas, one person saying solid. What does vapor mean? Vapor means a gas. So this is a gas. If we look at the periodic table, bromine is a liquid at room temperature. That's why its symbol is in blue on this periodic table. That indicates the physical state at room temperature. But this is not necessarily happening at room temperature. And so they're giving us this clue, vapor, that it's a gas. To give, so there's our arrow. And here's the formula. Crystalline manganese 4 bromide. So it's manganese 4 plus. We know that because of the Roman numeral here. Bromide, what kind of an ion does bromine form? Look at the periodic table and how many columns over from the noble gases? It's -1. So bromine, -1. And when we combine those, we're going to end up with MnBr4. Because there's a 4 plus charge on the manganese, each of the bromines is -1. We need 4 of them to balance the charge. Because ionic compounds have to be electrically neutral. And what's the state of this? It's a solid. Crystalline. Think of a crystal. Is a crystal a solid, a liquid, or a gas? It's a solid. So this is going to be a solid. What do we need to do to balance this equation? Yeah, if we put a 2 in front of Br2, that'll give us 4 bromines, and then we've got 4 bromines on the right side. There's 1 manganese on each side. These equations tend to be simpler to balance, and so it's a good place to start practicing balancing equations. Any questions?